My name is Abhishek. I'm going to present a PPT on developing a stemma for Sanskrit text. Our project is guided by Ms. Jayasri Nair. The team members other than me are Midun Sabulal, Suraj S. Nair and Yadu Murali M. Introduction. Sanskrit is a morphologically rich language. The words in Sanskrit have many inflections or variations. So, processing such a language is challenging. Stemming is a pre-processing step in NLP. It reduces inflected words to its root form. Stemma. Stemma is a linguistic tool which does stemming. It reduces inflected words into its stem or roots by removing affixes of the inflectional word. In Sanskrit, the stem is called as Pratipadikam for nouns and Dhatu for verbs. For example, Ramasya, which will be stemmed as Ram plus Sya. Background. Natural language processing, or shortened as NLP. It is a technology used in computers to make computer understand humans' natural language. In this technology, the computers has to read, decipher and understand human language in a very valuable manner. Most of the NLP technologies rely on machine learning. It is used in sentiment analysis, speech recognition, text classification, machine translators and question answering, etc. Some of the softwares which use NLP are Microsoft Word, Grammarly, Google Assistant, Alexa and Siri. Stemming is an important pre-processing step of most of the NLP techniques. Stemming is a process where a inflected word is processed out as the stem. Motivation. We can find several stemmers for English, but if we take the case of Indian languages, there are very few. This is because Indian languages are morphologically very rich, so making it very hard to create a stemmer for any Indian language. Efficient Sanskrit stemmers are very rarely found because of the complex nature of Sanskrit. The stemmer we aim to create will be helpful for Ayurveda students and doctors to understand and analyze the words in Sanskrit in their textbooks. This will also help other Sanskrit enthusiasts to better understand Sanskrit writings. Search engines will be providing better results due to this stemmer. It will also help information retrieval and text clustering systems. Project description. In the figure, we can see an inflected word is passed into the stemmer module, which is connected to dictionary of roots, and a stemmed word is given as output. The process happening is first an inflected word, that is a word with the stem and affix is given as an input to the stemmer module. The stemmer will process the input using several stemming algorithms. Once the stemming process is done, the stemmed word is obtained as output from the module. Here, Ramasya is the stemmed word, which is stemmed out as Rama plus Sya. Scope. The stemmer we aim to create will be built focusing mainly on stemming Sanskrit verbs. Sanskrit verbs have an inflection system for different combinations of tense, aspects, mood, voice, number, and person. Sanskrit have 3 persons: first person, second person, third person, and 3 numeric forms: singular, dual, plural. Project implementation overview. The stemmer we aim to create will be implemented using Python as the main programming language, in addition with Natural Language Toolkit and Indian Natural Language Toolkit. Similar system description. These are some of the similar systems that we could find from the papers we read. The crops based stemmer used in paper 5 collects all the words in the crops and then identifies the potential suffixes based on their frequency of occurrences. K. Subba and team at paper 6 is developed a hybrid inflection stemmer and a rule based derivational stemmer for Gujarati. The inflection stemmer has an accuracy of 90% and the derivational stemmer has an accuracy of 70%. The suffix stripping algorithm used in paper 3 is a good example that efficient stemmers can be developed for old resource scarce languages. Use of the dictionary will also reduce errors. Developing an MSAG model for Kannada is discussed in paper 4. The demand and practical usability for such model is evident in this paper. A.G. Giovanni and team at paper 2 gives a clear-cut idea of the existing algorithms for stemming. Conclusion. Stemmer is a linguistic tool which acts as a preprocessor for many natural language processing techniques. Stemming is done by removing affixes of inflectional words. There are rule based as well as statical based stemmers. We aim to develop a stemmer for a highly inflectional language like Sanskrit, and it is a more challenging task than doing the same for some other language. They are used in IR systems, text clustering systems, search engines, etc. References. These are some of the references that we took from IEEE and Springer websites, and these all were very informative, and there we got many ideas which we can implement in the stemmer that we aim to create. Thank you.